Abstract, organizations deploying artificial intelligence at scale face a fundamental structural challenge. Traditional hierarchies built for human decision making prove inadequate when algorithms assume core operational roles. This article examines how AI first operations, where AI systems execute primary workflows rather than merely supporting human tasks, necessitate new organizational forms that blend human oversight with algorithmic autonomy. Drawing on research across technology, financial services, healthcare, and logistics sectors, we identify how leading organizations are reconfiguring decision rights, accountability frameworks, and team structures to accommodate hybrid human AI operations. The analysis reveals that successful AI first organizations adopt platform based structures with distributed authority, create new coordination roles bridging technical and operational domains, and establish governance mechanisms that maintain strategic human control while enabling algorithmic execution. These structural innovations carry significant implications for organizational performance, workforce adaptation, and operational resilience in an increasingly automated economy. The integration of artificial intelligence into business operations has moved beyond experimental phases into production scale deployment, fundamentally altering how work gets organized and coordinated. Unlike earlier waves of automation that replaced discrete tasks within existing workflows, contemporary AI systems increasingly assume end to end process ownership, making decisions, orchestrating resources, and adapting operations in real time with minimal human intervention. This shift from AI as tool to AI as operator creates structural tensions that traditional organizational hierarchies struggle to resolve. Consider the operational reality. Algorithmic systems now autonomously approve loans, diagnose medical conditions, route delivery vehicles, and moderate content at scales and speeds that preclude conventional supervisory oversight. Yet these same systems require human judgment for edge cases, strategic direction, ethical boundaries, and continuous improvement. The resulting organizational challenge is not simply technological, but fundamentally structural. How do we design organizations where authority, accountability, and coordination flow through both human hierarchies and algorithmic networks simultaneously? The stakes are substantial. Organizations that maintain traditional structures while deploying AI first operations often experience coordination breakdowns, accountability gaps, and innovation bottlenecks as human managers struggle to oversee processes they cannot directly observe or control. Conversely, organizations that successfully reconfigure their structures report significant performance advantages. Faster decision cycles, improved resource utilization, and enhanced adaptability to market changes. This article examines how forward thinking organizations are redesigning their structures to thrive in AI first operations, offering evidence based guidance for leaders navigating this transition. The AI first operations landscape. Defining AI first operations in organizational context. AI first operations represent a qualitative shift from traditional automation. Where conventional systems execute predefined rules within narrow parameters, AI first operations leverage machine learning algorithms that adapt behavior based on patterns in data, often making context specific decisions without explicit human approval for each action. Research distinguishes AI first operations by three characteristics: algorithmic decision making authority over primary workflows, continuous learning and adaptation based on operational feedback, and human involvement structured around boundary setting and exception handling rather than direct supervision. Davenport and Ronenke, 2018. This operational model fundamentally alters traditional management functions. Span of control, a foundational concept in organizational design, becomes nearly meaningless when an algorithm supervises thousands of transactions simultaneously. Similarly, hierarchical reporting relationships blur when AI systems integrate inputs from multiple functional areas and stakeholder groups without following traditional departmental boundaries. These changes force organizations to reconsider basic structural assumptions about coordination, control, and accountability that have anchored organizational design since the industrial era. Prevalence, drivers, and state of practice. AI first operations have achieved significant penetration in sectors where high volume, data rich processes create favorable conditions for algorithmic decision making. Financial services institutions now route substantial portions of routine customer service inquiries through AI systems with minimal human intervention, while logistics companies deploy AI to make real time routing decisions affecting millions of daily deliveries. Bughin et al., 2017. Healthcare organizations increasingly rely on AI for diagnostic support, treatment recommendation, and patient monitoring, though regulatory and liability concerns maintain stronger human oversight requirements than in other sectors. Several converging factors drive this acceleration. Cloud computing infrastructure reduces the capital requirements for deploying sophisticated AI systems, while advances in machine learning enable algorithms to handle increasingly complex, ambiguous decision contexts. Competitive pressure amplifies adoption. Organizations observe rivals achieving step function improvements in speed, cost, and customer experience through AI first operations and face intense pressure to follow. The COVID-19 pandemic compressed digital transformation timelines, forcing organizations to rapidly deploy remote, automated operations that previously faced internal resistance. Yet adoption remains uneven, and structural adaptation often lags operational deployment. Many organizations have deployed AI in business functions without fully restructuring teams or redefining roles to accommodate AI first operations. This gap creates what organizational researchers term structural drag, where new technologies operate within outdated organizational forms, limiting their potential value while creating coordination challenges and accountability confusion. Organizational and individual consequences of AI first operations. Organizational performance impacts. Organizations that successfully restructure for AI first operations demonstrate measurable performance advantages across multiple dimensions. Decision velocity improves dramatically. Companies report substantial reductions in time to decision for routine operational choices, freeing human managers to focus on strategic, high ambiguity decisions. Fountain et al., 2019. Operational efficiency gains prove equally substantial, with leading AI first organizations achieving significant cost reductions in process intensive functions through algorithmic resource allocation and continuous optimization. Quality and consistency metrics often improve under AI first operations when properly governed. Algorithmic decision making eliminates human cognitive biases and fatigue related errors in repetitive tasks, while maintaining consistent application of decision criteria across contexts. However, these quality improvements depend critically on organizational structure. When AI systems operate within siloed traditional departments, they may optimize local metrics while degrading overall system performance, a coordination failure that appropriate structural design can prevent. Adaptability represents perhaps the most strategically significant performance dimension. Organizations with structures designed for AI first operations demonstrate faster response to market shifts, as algorithmic systems continuously adjust operations based on changing patterns without requiring formal management intervention. Research examining organizations during periods of demand volatility found that structurally adapted AI first operations maintain service levels through rapid inventory and staffing adjustments, while traditionally structured competitors experience service degradation despite deploying similar AI technologies. Individual well being and workforce impacts. The human workforce consequences of AI first operations vary dramatically based on organizational structural choices. Poorly managed transitions, where AI deployment proceeds without thoughtful role redesign, correlate with elevated employee anxiety, decreased job satisfaction, and increased turnover among both displaced workers and those whose roles change significantly. Raish and Krakowski, 2021. Employees report feeling surveilled by AI monitoring systems, frustrated by loss of autonomy, and uncertain about career development when traditional advancement paths disappear. Conversely, organizations that proactively restructure work around human AI collaboration report different outcomes. When organizations create explicit roles bridging human judgment and algorithmic operations, such as AI trainers, exception handlers, and algorithm auditors, employees report higher job satisfaction and perceive AI as augmenting rather than threatening their work. Research on customer service operations found that when organizations restructured teams to pair human agents with AI assistants, rather than replacing agents, both customer satisfaction and employee engagement improved as humans focused on complex, relationship intensive interactions, while AI handled routine inquiries. Wilson and Doherty, 2018. Skills evolution presents both challenge and opportunity. AI first operations demand workforce capabilities spanning data literacy, algorithmic reasoning, cross functional collaboration, and ethical judgment. Competencies unevenly distributed in current workforces. Organizations that invest in systematic reskilling as part of structural transformation report smoother transitions and maintain institutional knowledge, while those attempting to restructure primarily through workforce replacement face knowledge loss and cultural disruption that undermines AI system performance. Evidence based organizational responses, platform based structural models. Leading AI first organizations increasingly adopt platform based structures that replace traditional functional hierarchies with modular, reconfigurable teams organized around data flows and algorithmic processes. Rather than departmental silos, marketing, operations, finance. These organizations structure work around cross functional pods or squads that combine technical specialists, domain experts, and operational staff with shared accountability for end to end processes powered by AI systems. Research examining platform based structures in AI first contexts reveals several effectiveness factors. Clear interface definitions, specifying how teams interact with shared AI infrastructure and with each other, prove essential for coordination. Distributed decision authority, where teams possess autonomy to optimize their domain while respecting system wide constraints, enables rapid adaptation without centralized bottlenecks. Importantly, platform structures require strong central governance of shared resources, data standards, and ethical boundaries to prevent fragmentation. Parker et al., 2016. Effective platform approaches include cross functional AI product teams with embedded data scientists, engineers, domain experts, and operations staff jointly accountable for algorithmic system performance. Shared services platforms providing common AI infrastructure, data pipelines, model deployment, monitoring, while enabling distributed teams to build domain specific applications. Marketplace models where internal teams both contribute to and consume AI capabilities, creating internal competition and innovation. Federated governance structures balancing central standards, ethics, security, data quality, with team level autonomy in implementation. Spotify reorganized around AI first content recommendation and personalization by creating autonomous squads with end to end ownership of specific user experience domains. Each squad includes machine learning engineers, product managers, designers, and content specialists who collectively manage the algorithmic systems serving their domain. This structure enables rapid experimentation and deployment. Squads ship updates continuously rather than through quarterly release cycles, while maintaining coherence through shared technical infrastructure and regular cross squad coordination forums. The structural redesign contributed to Spotify maintaining recommendation relevance despite exponential content growth and increasingly fragmented user preferences. Algorithmic governance and oversight roles. Effective AI first structures create specialized roles and teams focused explicitly on algorithmic governance, monitoring AI system performance, ensuring ethical operation, managing exceptions, and coordinating continuous improvement. These governance functions prove essential for maintaining accountability and strategic control, even as operational authority shifts to algorithms. Research indicates that organizations with clearly defined algorithmic governance roles experience fewer adverse incidents, maintain stronger regulatory compliance, and sustain higher trust among stakeholders than those treating governance as an informal management add on. Raish and Krakowski, 2021. Governance structures vary by industry context and risk profile. Financial services organizations typically implement multi layered oversight with model risk management teams, ethics review boards, and regulatory compliance specialists. Healthcare organizations emphasize clinical oversight roles where medical professionals review algorithmic recommendations, particularly for high stakes decisions. Across sectors, successful governance structures share common elements. Explicit decision rights defining when human approval is required, clear escalation paths for algorithmic anomalies, and systematic feedback mechanisms capturing human override decisions to improve future algorithmic performance. Governance approaches demonstrating effectiveness. Model risk management teams with authority to approve, restrict, or decommission algorithmic systems based on performance monitoring and risk assessment. Ethics and fairness review boards providing structured evaluation of AI systems for bias, discrimination risks, and alignment with organizational values. Human in the loop exception, handlers managing cases that algorithms flag as outside their competence boundaries, with structured processes for feeding lessons back to improve algorithms. Algorithmic auditors conducting regular reviews of AI system decisions, identifying patterns of error or unintended consequences. JP Morgan Chase established a firm-wide AI governance structure, including a centralized model risk and development team that reviews all AI systems before production deployment, ongoing monitoring for model drift and performance degradation, and clear escalation protocols when algorithmic decisions fall outside acceptable parameters. The structure includes domain-specific oversight committees in lending, trading, and compliance, ensuring both technical rigor and business context inform governance decisions. This multi-layered approach has enabled the bank to scale AI deployment across hundreds of use cases while maintaining regulatory compliance and avoiding major algorithmic incidents that have troubled competitors. Hybrid team configurations and role evolution. Organizations succeeding in AI first operations fundamentally redesign roles to emphasize human AI collaboration rather than viewing automation as simple job replacement. Research on effective hybrid teams reveals that performance improves when organizations create clear role definitions, specifying how humans and AI systems contribute complementary capabilities to shared objectives, with explicit protocols for collaboration and decision authority. Wilson and Daugherty, 2018. Several hybrid team patterns emerge across industries. Augmentation models pair individual workers with AI assistants that handle routine subtasks, data retrieval, or preliminary analysis, while humans make final judgments and manage stakeholder relationships. Relay models structure work as sequential handoffs between AI systems and humans, with algorithms performing initial processing and humans handling exceptions or complex cases. Collaboration models integrate human and AI contributions in real time, such as surgeons working with AI diagnostic systems or traders operating alongside algorithmic market analysis. Team configuration approaches showing positive outcomes. AI augmented specialist roles, where domain experts gain amplified capacity through AI assistants handling information gathering, routine analysis, and administrative tasks. Algorithm to human relay workflows with AI systems performing initial triage, classification, or processing and escalating cases, meeting defined criteria to human specialists. Collaborative hybrid teams where humans and AI systems contribute simultaneously to decisions, combining algorithmic pattern recognition with human contextual judgment and creativity. AI trainer and supervisor roles responsible for continuously improving algorithmic systems through feedback, teaching by example, and identifying new scenarios. Stitch Fix, the online personal styling service, built their entire operating model around hybrid human AI teams. Data scientists and machine learning engineers create algorithms that analyze customer preferences, inventory, and style trends to generate initial clothing recommendations. Human stylists then review these algorithmic suggestions, applying judgment about individual customer context, lifestyle fit, and style evolution that algorithms struggle to capture. Crucially, stylist feedback becomes training data, improving future algorithmic recommendations. This structural design enables Stitch Fix to serve millions of customers with personalized attention at scale, unachievable through either pure automation or traditional human styling. Dynamic authority and decision rights frameworks. AI first operations demand new frameworks for allocating decision authority that move beyond static hierarchical assignment. Leading organizations implement dynamic decision rights systems where authority shifts between humans and algorithms based on context, confidence levels, and risk assessment rather than fixed organizational charts. Research examining these adaptive authority systems finds they enable both operational speed and appropriate human oversight, provided organizations establish clear criteria governing authority allocation and create transparency about who or what makes each decision. Farage et al., 2018. Effective dynamic authority frameworks typically specify decision thresholds, quantitative or qualitative criteria determining when algorithmic systems can act autonomously versus when human approval is required. These thresholds often incorporate multiple factors: financial impact, strategic significance, novelty, has the algorithm encountered similar situations previously, confidence scores from the AI system itself, and regulatory requirements. Importantly, successful frameworks include processes for periodically reviewing and adjusting thresholds as algorithms improve and organizational trust in AI systems evolves. Dynamic authority approaches demonstrating value. Confidence based escalation, where AI systems assess their own certainty and automatically escalate low confidence decisions to human reviewers. Risk tiered decision frameworks allocating authority based on potential impact, with algorithms handling low stakes decisions autonomously while humans review high consequence choices. Learning phase authorities that increase algorithmic autonomy gradually as systems demonstrate consistent performance, beginning with human review of all decisions and systematically reducing oversight. Context triggered oversight, where specific situational factors, customer value, regulatory sensitivity, public visibility, automatically invoke human review regardless of algorithmic confidence. Capital One implemented dynamic decision rights in their credit underwriting operations, allowing AI systems to autonomously approve applications meeting specific confidence and risk criteria while escalating edge cases to human underwriters. The bank's framework assigns authority based on multiple factors: predicted default probability, loan amount, applicant profile novelty, and model confidence scores. Importantly, the framework incorporates continuous learning. As algorithms demonstrate reliable performance on previously escalated case types, the authority thresholds adjust to expand algorithmic autonomy. This approach enables Capital One to process the majority of applications instantly while ensuring human judgment applies to genuinely ambiguous or high stakes decisions. Data stewardship and algorithmic transparency structures. Organizations operating AI first systems increasingly recognize that data governance and algorithmic transparency require dedicated structural attention. Leading organizations create formal data stewardship roles and teams responsible for ensuring data quality, access, privacy, and ethical use, recognizing that algorithmic performance depends fundamentally on data integrity and that poor data governance creates both operational and reputational risks. Redman, 2018. Structural approaches to data stewardship vary but typically include centralized data governance teams establishing standards and policies, distributed data stewards embedded in operational units ensuring local compliance and data quality, and cross-functional data councils adjudicating conflicts between data access and privacy or security concerns. Effective structures also create algorithmic transparency mechanisms, systems and roles dedicated to explaining how AI systems make decisions, particularly for stakeholders affected by algorithmic choices. Data governance and transparency structures showing effectiveness. Chief Data Officer roles with enterprise-wide authority over data standards, access policies, and quality metrics, supported by distributed data stewardship teams. Data product management treating data assets as products with clear ownership, quality standards, and service level agreements for teams consuming data. Algorithmic explainability specialists responsible for creating interpretable views of AI system decision logic for regulators, customers, and internal stakeholders. Data ethics review processes providing structured evaluation of how data collection, use, and algorithmic processing align with organizational values and stakeholder expectations. Cleveland Clinic restructured their health informatics organization to support AI first clinical decision support, creating a dedicated analytics and data institute with clear authority over health data governance. The institute includes both centralized data quality and standards teams and embedded data stewards working within clinical departments to ensure data capture accuracy and appropriate use. Importantly, the structure includes an AI ethics committee with representatives from clinical practice, data science, legal, and patient advocacy, reviewing all AI systems before deployment. This structural attention to data governance and transparency has enabled Cleveland Clinic to deploy AI driven clinical tools while maintaining physician trust and regulatory compliance in a highly sensitive domain. Building long term adaptive capacity, continuous learning and improvement systems. Organizations achieving sustained success with AI first operations embed continuous learning mechanisms into their structures rather than treating improvement as periodic management intervention. Research on organizational learning in AI contexts reveals that high performing organizations create formal feedback loops capturing how algorithmic systems perform in practice, how humans interact with and override algorithms, and how operational contexts change. Then systematically incorporate these insights into algorithmic and structural improvements. Raish and Krakowski, 2021. Effective learning systems operate at multiple organizational levels. Frontline feedback mechanisms enable workers directly interacting with AI systems to report errors, edge cases, and improvement opportunities quickly without bureaucratic barriers. Team level retrospectives create regular forums for reflecting on human AI collaboration effectiveness and identifying structural friction points. Organization level analytics synthesize patterns across local experiences, identifying systematic issues requiring broader structural or algorithmic changes. Structurally, leading organizations often create dedicated continuous improvement teams focused on human AI system performance. These teams differ from traditional IT or operations improvement groups by combining technical AI expertise with deep operational knowledge and organizational design capabilities. Their mandate includes monitoring algorithmic performance metrics, analyzing human override patterns, facilitating cross team learning, and recommending structural adjustments to improve human AI coordination. Critically, these teams possess authority to implement changes rather than merely making recommendations, enabling rapid learning cycles. Distributed leadership and coordination mechanisms. AI first operations function most effectively under distributed leadership models that move beyond traditional hierarchical command structures. Research examining coordination in AI intensive organizations finds that centralized decision making creates bottlenecks incompatible with the speed and complexity of algorithmic operations, while purely decentralized approaches risk fragmentation and inconsistent stakeholder experiences. Farage et al., 2018. Successful organizations balance these tensions through distributed leadership, where strategic direction and boundary setting remain centralized but operational authority disperses across multiple human and algorithmic actors. Distributed leadership in AI contexts requires robust coordination mechanisms, replacing traditional hierarchical control. Leading organizations employ several structural approaches: regular cross functional synchronization forums, where teams operating related AI systems share insights and coordinate decisions, shared dashboards providing transparency into algorithmic system performance and enabling pattern recognition across organizational boundaries, and clearly defined escalation paths enabling rapid coordination when local decisions have broader implications. Importantly, distributed leadership demands different capabilities from formal leaders. Rather than directing specific decisions, leaders in AI first organizations focus on setting strategic priorities, establishing decision principles and constraints, building organizational capabilities, and resolving coordination challenges that cross functional teams cannot address independently. This shift from directive to enabling leadership requires both role redesign and leader development, recognizing that managers successful in traditional hierarchies may struggle in distributed AI first structures without explicit support for capability building. Purpose, culture, and human agency preservation. Organizations sustaining high performance in AI first operations invest deliberately in cultural dimensions that preserve human agency and organizational purpose, even as algorithms assume operational authority. Research on algorithmic management reveals a consistent risk. As AI systems make more decisions, human workers may experience reduced autonomy, diminished sense of purpose, and weakened organizational commitment, ultimately undermining the discretionary effort, creativity, and judgment that AI systems cannot replicate. Raish and Krakowski, 2021. Structurally, leading organizations address this challenge through several approaches. They create opportunities for meaningful human contribution at strategic and creative levels, even as algorithms handle routine operations. Explicitly designing roles around capabilities uniquely human rather than merely what AI cannot yet do. They involve workers in AI system design and continuous improvement, creating psychological ownership and ensuring algorithmic tools genuinely augment rather than frustrate human work. They maintain transparency about how algorithmic decisions are made and create accessible channels for questioning or challenging algorithmic outputs when human judgment suggests errors. Perhaps most fundamentally, successful AI first organizations ground their structures in clear organizational purpose that transcends operational efficiency. They articulate how AI enablement serves broader stakeholder value, better patient outcomes, improved customer experiences, enhanced employee capability, rather than positioning automation primarily as cost reduction. This purpose clarity provides cultural cohesion and motivational foundation, even as specific roles and structures evolve rapidly in response to technological capability. Conclusion: the transition to AI first operations represents a fundamental organizational design challenge, not merely a technological implementation project. Organizations that recognize this reality and proactively restructure to accommodate hybrid human algorithmic operations demonstrate significant performance advantages, while those attempting to overlay AI onto traditional hierarchical structures experience coordination failures, accountability gaps, and workforce disruption that limit value realization and create substantial risks. The evidence reviewed here points towards several structural imperatives for leaders navigating this transition. Platform based organizational models that organize work around data flows and end to end processes, rather than traditional functional silos, enable the cross disciplinary collaboration and rapid adaptation AI first operations demand. Specialized governance roles and clear dynamic authority frameworks provide accountability and appropriate human oversight without creating bottlenecks incompatible with algorithmic speed. Hybrid team configurations and thoughtful role evolution preserve human agency and leverage uniquely human capabilities while enabling algorithmic scale. Critically, successful structural adaptation extends beyond formal organizational charts to encompass decision rights, coordination mechanisms, leadership models, and cultural foundations. Organizations building long term adaptive capacity invest in continuous learning systems, distributed leadership capabilities, and purpose clarity that sustains organizational coherence even as specific structures evolve. They recognize that AI first operations create ongoing structural experimentation rather than a one time reorganization, requiring leaders comfortable with ambiguity, learning, and iterative adaptation. The organizations profiled here, spanning financial services, healthcare, retail, and technology sectors, demonstrate that structural innovation for AI first operations is both feasible and valuable. Their experiences offer actionable guidance. Start with clear purpose and stakeholder value rather than technology capability. Involve frontline workers in design to ensure structures support rather than frustrate human work. Establish governance and transparency mechanisms before scaling algorithmic authority. Create explicit learning systems rather than assuming structures will naturally evolve. And recognize that leadership capabilities must shift from directive control to strategic boundary setting and coordination facilitation. As AI capabilities continue advancing and deployment accelerates, organizational structure will increasingly determine which organizations thrive and which struggle in an algorithmic economy. The structural innovations emerging from early adopters provide valuable foundations, but each organization must adapt these patterns to their specific context, culture, and strategic objectives. The imperative is clear. Organizational design must evolve as fundamentally as the technologies reshaping operations, or structural drag will prevent organizations from realizing AI's transformative potential.